the leaking landfill climate bomb, and why optimizing biogas collection in modern landfills is so important. We're leaking a climate bomb, and we already know how to stop it. Every landfill on Earth is releasing a gas 28 times worse than carbon dioxide. We have the technology to capture it, but most landfills aren't using it. Here's why that has to change now. We have crossed a threshold. The 1.5 degrees Celsius limit, the line scientists told us we must not cross, is now behind us. Not a warning anymore. A reality. And yet, right now, beneath the surface of thousands of landfills around the world, a silent crisis is making it worse, and an extraordinary opportunity is being left on the table. Every ton of food waste, garden clippings, and paper buried in a landfill quietly produces one of the most potent greenhouse gases on the planet. Methane. A gas 28 times more effective at trapping heat than carbon dioxide over a century. And in too many landfills, that gas is simply escaping into the atmosphere. Uncontrolled. Uncaptured. Unforgivable, when the technology to stop it already exists. Landfills are the third largest source of human-related methane emissions in the United States alone, responsible for approximately 14.4% of those emissions in 2022. A Harvard study found that actual methane collection efficiency at operating landfills is closer to 50%, far below the 75% that regulators typically assume. That means roughly 1 in every 2 molecules of methane produced beneath our feet is escaping. Rising. Warming. This is not inevitable. It is a failure of engineering and of urgency. But here's what makes this story different from so many climate stories. This is a problem we already know how to solve. When organic material, food, paper, wood, is buried in a landfill, it begins to break down without oxygen, in a process called anaerobic decomposition. The result is landfill gas, a mixture of roughly 50% methane and 50% carbon dioxide, with small amounts of other compounds. Left uncaptured, that methane migrates upward through the waste and escapes. Captured, it becomes a resource. Methane is, after all, the primary component of natural gas. It can generate electricity. It can fuel vehicles. It can heat homes. The question is not whether we can capture it. The question is why we aren't capturing more of it. As of 2025, the United States has 589 landfill biogas facilities in operation, an 18.5% increase since 2020, with the capacity to capture 521 billion cubic feet of gas annually. That's enough energy to power the electricity needs of 3.3 million homes, or fuel more than 5 million passenger vehicles every year. In 2024 alone, developers added the largest single-year increase in capture capacity on record. And yet, 470 landfills are still flaring gas that could instead be captured, upgraded, and used. 470 landfills. Burning off a resource. Adding to the problem they could be solving. The gap between what we are capturing and what we could be capturing represents one of the most actionable climate opportunities on Earth. It comes down to 3 integrated components, working in harmony. First, vertical extraction wells. Drilled into the waste mass at carefully calculated intervals, typically 15 to 30 meters apart, these wells create a network of collection points throughout the landfill body. Second, horizontal collector pipes. These extend the reach of the collection system through older parts of a landfill. Third, and perhaps most critical, impermeable geomembrane covers. These fusion-welded HDPE liners create an airtight seal across the landfill surface. Without them, methane migrates laterally and escapes through surface cracks before it ever reaches a collection well. With them, pressure differentials are maintained, oxygen intrusion is blocked, and the methane-producing microorganisms beneath the surface thrive. The key operational lever is differential pressure, maintaining a vacuum of between 25 and 50 centimeters of water across the wellheads. Too little vacuum, gas escapes at the surface. Too much, oxygen is drawn in, inhibiting the microorganisms that produce the gas. It's a precise balance, and getting it right is the difference between a system capturing 50% of available methane and one capturing 85% or more. The impact of optimized collection is not theoretical. At a landfill in Kansas, real-time pressure monitoring and automated wellfield tuning achieved a 32% increase in methane capture over 4 years. That single improvement was equivalent to removing 82,000 gasoline-powered vehicles from the road for an entire year. At a facility in Washington state, declining gas production was reversed. Methane yields increased by 12% over 2.5 years, improving gas quality to the point where the upgraded product could meet renewable natural gas pipeline standards. These are not marginal gains. In a world where every fraction of a degree matters, every percentage point of additional capture matters. Gas production peaks within the first 15 to 25 years after a landfill's closure. That is the window in which the most methane is produced, and the most value, and the most damage, is waiting to be realized. Design the system now. Install it correctly from the beginning. Maintain it rigorously. Because a landfill without an optimized collection system is not a neutral piece of infrastructure. It is an active, ongoing source of climate damage. Worse, it is a missed economic opportunity. Landfill gas electricity can be produced at as little as 3.8 cents per kilowatt-hour, well below national retail rates. Renewable natural gas, or RNG, not electricity, now makes up 40% of all landfill gas energy output in the United States, up from 19% just 5 years ago. Capital investment in new facilities exceeded $1 billion per year in both 2023 and 2024. The economics are compelling. The technology is proven. The climate imperative is urgent. A properly designed, properly maintained biogas collection system can recover 85% or more of the methane produced beneath its surface. That is not just good engineering. In a world that has already crossed 1.5 degrees, that is a moral obligation. Machine learning models can now optimize well scheduling and pressure management in real time, anticipating changes in gas production before they become losses. Biofilters are enabling the removal of trace contaminants, siloxanes, hydrogen sulfide, volatile organic compounds, allowing more landfills to meet the stringent quality standards required for pipeline injection. Modular, factory-fabricated cover panels are cutting installation time by up to 40%, removing barriers for smaller or more remote sites. The tools are ready. The market is ready. The planet needs it now. Beneath every modern sanitary landfill is a choice. Let the methane escape and pay a cost that every living thing on Earth will bear. Or capture it and turn one of our most persistent environmental liabilities into clean, renewable energy. We have already crossed 1.5 degrees. That doesn't mean we stop fighting. It means we fight harder, smarter, with every tool we have. Optimized biogas collection is one of those tools, proven, scalable, and available today. The gas is there. The technology is there. The only question is whether we choose to use it.